Hello everyone, welcome back to my channel. My name is TJ Astrophysics. I'm a student at LLFP and today we're going to be discussing meteors, more commonly known as shooting stars. If you've ever seen a meteor, then you probably watched the evaporation of a bit of the solar system's history. But what are you looking at? What are meteors and how do they work? Now, if you watched my video on how the universe was created, you now know that there's a lot of leftover debris in the solar system in the form of comets, asteroids, and meteoroids. A meteoroid is a small body moving through the solar system. If that meteoroid enters the Earth's atmosphere, it becomes a meteor. And if any pieces from that meteor hits ground, it will be called a meteorite. What happens is, when a meteoroid enters the Earth's atmosphere, it starts to evaporate because of its friction with the air molecules in the atmosphere. And this is what causes it to appear as a streak of light in the sky. Now, some of these pieces may have existed long before planets or even the sun was formed, while others may have been part of an asteroid, or the moon, or even Mars. And that's why scientists use meteorites to know more about the early ages of the solar system. Every day and night, our Earth is showered with hundreds of tons of space material. Whether or not that space material gets to the surface of the Earth depends on its size. Now, most meteors are small, so about the size of a dust particle. Yes, the size of a dust particle. Most people think that meteors are huge, but they're really not that big. But bigger meteors can survive through the dense air of the Earth's atmosphere and hit the surface of the Earth. But what about really big meteors? Can they hurt us, and how often do they hit? That's a very good question. Our Earth has been getting bombarded by solar debris for over 4 billion years. But there is still a fairly large amount of solar debris out there. A meteor large enough, so about 1 kilometer in diameter, would cause really big problems if it hit Earth. So I have this app called Universe Sandbox where I can run multiple simulations launching different meteors towards the Earth to see their effects. Here we're starting with a meteor of a radius of 1 meter, launching it at a speed of 20 kilometers per second, which is the average speed at which a meteor hits Earth. So we just started the simulation. The 1 meter radius meteor is heading towards Earth. And as we can see, the results are absolutely catastrophic. It sent a shockwave across the globe, and we can even observe after effects in the north and west of Australia. We're running the simulation again, this time with a meteor of a radius of 1 kilometer, again at 20 kilometers per second, which is the average speed at which a meteor hits Earth. And as you can see, the results are even worse. The after effects affect the whole entire continent. We even have oceans that are evaporating, and it's affecting almost a quarter of the whole entire globe. The meteor that hit the dinosaurs really long ago is estimated to have a radius of up to 80 kilometers. Launching it at a speed of 20 kilometers per second again, we're now going to run that simulation, and we're going to see what happened to the Earth. Just as expected, the results are even worse. We see fragments of the Earth spreading into space. There are even after effects, shockwaves, multiple shockwaves, and half of the globe has been completely destroyed. But fortunately, meteors of that size only hit Earth every million years or so. And on top of that, planetary scientists are constantly on the lookout for such objects and will definitely warn us for such potential dangers. Meteors are most common when the orbit of the Earth intersects cometary streams, which are areas where there's a lot of solar debris in the form of dust and ice. When that happens, the Earth experiences a meteor shower. During these meteor showers, you can expect to see up to 100 meteors per hour. That's a bit over 1.5 meteors per minute. There are 8 major meteor showers each year, and they are named after the constellation they seem to radiate from in the sky. The best known meteor showers are Quadrantids, Lyrids, Eta Aquarids, Arietids and Boutids, Southern Delta Aquarids, Perseids, Orionids, Leonids, and Geminids. Each of these are caused by Earth moving through streams of solar debris in space. If you haven't seen a meteor shower yet, I strongly advise you to. You don't need binoculars, nor a telescope, nor any equipment at all. Just go on Google and look up when the next meteor shower is going to be. Get as far away from the city as you possibly can to minimize light pollution. Lay down on the ground and observe the meteors. It is a wonderful experience, trust me. Thank you all for watching. I really hope you enjoyed this video. If you did, please give it a like down below, and while you're there, consider subscribing. If you have any suggestions for future videos or any questions on this one, leave them in the comments down below and I'll try to answer if I can.